Good morning, everybody. This research work is entitled EDK-LEACH, Improving Leach Protocol-Based Machine Learning in Wireless Sensor Networks. This work has been done by Dr. Lechani from the University of Boumerdès, Algeria. The outline of this presentation is as follows. We have an introduction, then we introduce the low energy adaptive clustering hierarchy protocol, i.e. LEACH protocol. Then we present the energy distance K-means LEACH protocol, EDK-LEACH. After this, we present the different results that we have got with a discussion. At the end, we have a conclusion. In the introduction part, the wireless sensor networks have increased the interest of both academics and industrialists. Their applications cover a wide range of industries, including agriculture, healthcare, smart buildings, the military, and underwater technology. A wireless sensor network is composed of several microelectronic devices called nodes, which are distributed to collect real-time data. These nodes transmit specific physical parameters they sense from their environment to the base station via direct sensory communication or through other sensors. Following data received and processing, the base station provides information to the end user to make decision. An effective energy management is necessary due to the sensor's limited energy, the non-rechargeable and non-changeable batteries. In this figure, we have the basic architecture of wireless sensor networks for clustering-based protocols, in which we have the base station surrounded by cluster heads and nodes. Furthermore, long-distance data transmission uses more energy than multi-hop path transfer. These issues led scientists to focus on clustering as an approach of minimizing use of energy and increasing network lifetime. By creating clusters and shortening transmission distances, clustering in wireless sensor networks seeks to reduce the energy needed to carry information from the source to destination. As a result, all nodes send straight their data directly to their cluster's head. After data have been compiled, aggregated, and compressed, the cluster head forwards it to the nearby cluster head or the base station. Now we present the LEACH protocol. The most widely used clustering routine protocol is the well-known LEACH, which selects clusters heads randomly. Due to random selection, a low-energy node may be chosen to become cluster head. This node will rapidly consume its energy and dies, causing holes region where nodes are unavailable and accelerating the death of the network in its entirety. Another disadvantage of Reach is that it forms clusters based only on the distances between nodes and cluster heads without considering other significant factors such as the optimal number of clusters or the manner they are distributed over the network. As a result, clusters differ in size, leading to imbalanced energy consumption. Consequently, two basic issues with the Leach algorithm have been identified: ineffective cluster head selection and unoptimized clustering. Now, the heart of our work is the energy distance K-means LEACH, or between parentheses EDK-LEACH. With the developments in artificial intelligence, the K-means is one of the unsupervised machine learning techniques that has been recently developed. It is employed in hierarchical routing protocols to more effectively segment the network into a given number of homogeneous clusters. This allows the energy consumption of the network's nodes and cluster heads to be divided evenly and substantially decreased. This work to enhance clustering strategies performance, a new protocol called EDK-LEACH, Energy Distance K-means LEACH, that combines both the LEACH protocol and machine learning K-means algorithm is presented. Before the cluster heads being elected, the area is divided into clusters using the K-means algorithm. The energy efficient objective function is then utilized to determine the cluster heads, taking into account both the node's remaining energy and distance from the centroid. Concerning the related works, several studies have focused on the geometric shape of clusters, circle or square or equal size sector clustering. Circular pathways are used to partition the network area into clusters, extending the life of wireless sensor networks beyond that of the traditional leech. In some other works, the routing algorithm divides the network into regular hexagons where the node's angle ratio, distance to the hexagon center, and throughput optimization threshold function are considered in the cluster head selection phase. Several studies explore the routing protocols in cluster-based wireless sensor networks with the goal of enhancing reach performance. These approaches have been based on fuzzy logic, genetic algorithms, or the social behavior of fish, birds, or ants when they move in a group searching for food. Among these algorithms are the particle swarm optimization and ant colony optimization algorithm. Artificial intelligence includes machine learning among its subfields. Machine learning is essentially described as machines' ability to simulate human behavior with a focus on pattern interpretation and analysis. Most machine learning algorithms belong to the following three categories: reinforcement learning, supervised learning, or unsupervised learning. Recently, the application of machine learning methods in wireless sensor networks has been investigated to enhance performance network without requiring reprogramming. Consequently, many protocols have emerged where K-means unsupervised machine learning was often implemented. In this work, based on which we examine and propose an enhancement of an unsupervised machine learning techniques of wireless sensor networks performances. For the method used, the unsupervised machine learning, as used in computer science and artificial intelligence, describes machine learning scenarios in which the data are not labeled. Among the issues discussed is clustering, which seeks to identify a pattern in an unlabeled data collection. However, clustering is considered as the most popular unsupervised learning algorithm, which divides unlabeled data points using an iterative process into distinct, non-overlapping groups. It splits the area into k predetermined clusters with the goal of maximizing the intercluster distance and minimizing the distances between the nodes in the cluster and the cluster centroid. We highlight the number of Predefined clusters that need to be formed during the process is determined in this case by K. Cluster generation phase. This stage begins with applying K-means algorithm, which is a simple technique used for splitting a certain data set into K predefined clusters. The fundamental concept is to define aleatory K centroids as far as possible away from each other, then associate each node of the wireless sense network to the closest centroid. When every node is mapped to a cluster, the first stage and the initial grouping are finished. The next step consists of computing k new centroids obtained from the previous step and considered as the barycenters of the clusters. Once k new centroids are established, a new stage consisting of an association between the wireless network's nodes set and allows the nearest new centroid needs to be performed. Finally, this loop is continuously executed until all k centroids converge gradually to a fixed position. The k-means purpose consists to reduce the total Euclidean distance between the cluster centroid and each of its members. Cluster head designation phase. Okay, the generation of homogeneous and balanced clusters is the key advantage of wireless sensor networks clustering based on k-means. In fact, in each, the nodes position either the remaining energy are not considered when the cluster heads chosen. A non-coverage area can then occur by selecting a low-energy node as the cluster head, which reduces the network's stability phase. For this reason, the overall energy efficiency of the network could decline. To address these issues, when the cluster head is chosen, our suggested protocol is designed in such a way that node's residual energy and its distance to the cluster's center are both considered. Cluster head designation phase. Okay, a node that is selected to the cluster head must keep this position for as long as its residual energy exceeds the dynamic threshold, which is established by the cluster's average node energy. The condition is required Okay, this condition is required to prevent the premature death of the cluster head, which would cause network section to be disconnected. The cluster head is replaced by a new node, which is selected according to the scores produced by the objective function provided by equation once its residual energy decreases below the dynamic threshold. Thus, with enough energy remaining in the network, allowing continuous monitoring and reporting. Even after each node's energy level drops below the initial threshold, the dynamic threshold ensures that cluster heads could be selected. As a result, this stage of our proposed algorithm makes the network far more resilient than it would be with traditional methods. For the different results that we have obtained, okay, for this section, we present computational results of our approach. The experimentations have been carried out using MATLAB 2018A to validate our new algorithm for minimizing node power consumption as well as extending network lifetime. Fig 2A and Fig 2B show how 100 randomly dispersed sensor nodes are organized into clusters in the area of interest using the Voronoi diagram and the K-means algorithm, respectively. Fig 3A and 3B represents the network lifetimes when the base station situated in the center of the surface and outside the area respectively. Fig 4a and 4b show the residual energy evaluation for the two protocols, which demonstrate the effectiveness performance of EDK-LEACH protocol compared to the LEACH protocol. Fig 5 summarizes the results of this research work to known results of the literature in histogram graphs. We can clearly see our proposed protocol that outperforms LEACH protocol in terms of dead nodes and energy consumption. Finally, as a conclusion, in this research work, an EDK-LEACH protocol is proposed. It is a K-means unsupervised machine learning based technique. LEACH is known is a known protocol where clusters are constructed after cluster heads election using probabilistic algorithm. The most important point is that by carrying out these processes, the load can be evenly distributed throughout all of the network sensors. The experimentation results of our protocol were compared with the known results of LEACH and showed on one side that the network lifetime has increased by more than 177% when the base station is in the center of the network, and by 160% when the base station is outside of the network. And thank you.